Welcome to our 12th video in the Python for Artificial Intelligence and Machine Learning series. My name is Dheeraj Choudhary, and today we will explore list comprehensions, a powerful and concise way to create lists in Python. List comprehensions provide a more elegant alternative to traditional loops for many data transformation tasks that we are going to see today. So list comprehensions are a concise and powerful way to create lists in Python. They combine the operation of looping, filtering, and transforming items into a single line of code. What might take 3 to 4 lines with the traditional loop that we have seen in our previous video can often be expressed in one elegant line with the list comprehension. Trust me, it's magic. The basic syntax follows a natural language pattern, a list of expressions for each item in an iterable. In machine learning, where data transformation is constantly needed, list comprehensions can make your code more readable and maintainable. So before I move to the basic syntax structure, let me just give you a glimpse of how exactly it reduces your code, as I just told you. So this is a traditional loop. Over here, this is a for loop where I say that we have to iterate for a range of 0 to 9, that is 10 minus 1, and every time we iterate we are going to do squares. So the value that we have of x, we are going to multiply it and we are going to append that as part of this squares list, that is the empty list that we have declared over here. So if you go ahead and run this, you can see the output is 0 1 4 9 16. Okay, that is now the same code, guys, in one line. See, the entire loop in one line. That is the beauty of list comprehension. If I go ahead and run this, you will see that we have the same output. That's how it is so powerful. Now, let's go ahead and understand the basic syntax and structure. So the basic syntax of comprehension consists of a square bracket containing an expression followed by a for clause. So the expression defines what will appear in the output list for each item in input iterable. So list comprehensions, as we spoke about, let's understand what exactly it is. It says that it consists of square bracket. List comprehension consists of square bracket. So first you define the square brackets. Then once you go inside the square brackets, there are three different types of thing which we define over here. First is the output expression. So the output expression is this, x raised to 2. So this is the output expression. Next, we have to define an item variable where the value is going to be stored as part of the variable. So this is the variable that we have defined, and this is the iterable. So this is the basic syntax of a list comprehension. Now let's understand a list comprehension for different for different use cases. So we will see it one by one. First, we already saw this example where we saw the list comprehension, where this is the output expression. That means the output we are going to get as part of this expression. This is the variable in which the value is going to get stored. So whenever we run the for loop, every time a new value from the iterable is getting stored as part of x, and this is the iterable, that how many times the loop will go on, and it goes ahead and gives that the final value to squares, and we go ahead and print the squares over here. So now let's see the other example. This is a new one. So over here, as I explained, now we will again talk from the basic syntax perspective. Char dot upper is our output expression. Okay. Now, what is our item variable? Char is our item variable. Now, what is our iterable? So over here we have a range which is going to go for the index of 0 to 4. What we have over here? It is a string. That means it is going to iterate through this string one by one, character by character. So first H, E, L, L, O, like that. Let's see. If I go ahead and run this, you will understand why I'm saying that. See that. So this was our iterable where we went towards it one by one. Every time we picked one and we converted that into an uppercase. Now the third one, again, let's talk from the syntax perspective. This is our output expression. Okay, and this is our item variable, and this is the tuple over which we are going to iterate. Okay, so when I go ahead and run this code, you will see what we are doing is every time we iterate for a value, we are saying num into 2. So we are multiplying everyone into 2. So 10 twos are 20, 20 twos are 40, 30 twos are 60. So this is how you can create a new list from a tuple by using list comprehensions. Now let's see what's next. So adding conditions. So list comprehensions become even more powerful when you add conditions to item filters. By adding an if clause at the end, you can specify which items from the original sequence should be included in the result. Only items that satisfy the condition will be processed by the expression. You can also combine multiple conditions using logical operators like and, or, and not. So this filtering capability is invaluable in machine learning for selecting relevant features, removing outliers, or filtering data points based on specific criteria. Let's understand this by some few examples. So if I will go ahead over here. So first I am defining our list over here, numbers. Okay, my list is defined. Now we are going to start with the example. What we are doing over here is, okay, we are looping through the list of numbers from 1 to 10. So when I say for x is in numbers, that means we are looping through this list that is from 1 to 10. The variable x represents each number. Variable x represents each number. Now inside this for loop, compared to the previous examples we saw, what is different? We have added a if condition, guys. So the condition if %2 equal to 0 filter outs only even numbers. Those are divided by 2 with no remainder. So the result includes just those even values. So this is a compact way of filtering a list without writing a full loop. In one line, you can do that. So if I go ahead and run this, see, so from the list of numbers from 1 to 10, now we only have the values printed, which are even numbers. Let's see the second example. So the second example is over here again. So again we loop through the numbers, a list of numbers from 1 to 10, but this time we use a different condition. So what is a different condition? If x is greater than 5. So over here it was for even number, but over here it is saying filter for numbers which are greater than 5. So whichever numbers are going greater than 5, we are going to consider them as large numbers, and those are the ones that we are going to filter out as part of our return value into large number variable that we have created. So this is a compact way to filter a list without writing a full loop like we did over here. So if I go ahead and run this, you will see which is whatever is greater than 0, that is 6 to 10, has been printed for us. Now let's see another example. The third example, so we loop over the same list but apply two conditions at once. So over here it was one condition. This time we have two conditions. I have taken both of them together. So x is greater than 5 ensures we only look for numbers greater than 5, condition number 1. Then x% 0 is equal to 0, which ensures that those all numbers are even. So the only values that meet both of the criteria is going to make it into the final list, that is our filtered numbers. Okay, so if I go ahead and run this, see, after first criteria, x is greater than 5, so nothing is been taken from x to 5. Then second criteria, it is looking for even numbers. So the first criteria is met, then we are just going ahead in second criteria. So second criteria, 6 even, both of the conditions are met, printed. 8 again added, 10 again added. So this is how you can use multiple conditions. Now Python list comprehensions also support conditional expression using the ternary if-else syntax. Unlike filtering with an if clause, condition expressions allow you to apply different transformations to the items based on a condition. So all items still remain in the result, but their values may be different. Note the important syntax difference in a conditional expression, that is ternary, is the condition if else appears before the for clause, while filtering it appears after it, as we saw. So in our previous example we were filtering it, that's why it was at the end, but over here it is going to be in a different place. So let's understand that with an example. So let me just minimize this. So first I'm going ahead and defining. Okay, so I have defined it over here. Now, what it is saying is the important point that you should be aware of. So the previous example that we saw, it was a filtering with an if else, but conditional expressions allow you to apply different transformation to items based on a condition. So so you have to note that there is a syntax difference between the previous and this one. In the previous one, we were only using the if condition over here, but over here the condition is in the other place. Okay, so the condition if else appears before the for clause while filtering it, while the filtering if condition appears after it. So what we're going to do is over here is first this example, this example, we loop through the numbers 1 to 5. That is numbers 1 to 5. We are going to loop through 1 to 5 as part of this for loop. We says for x in numbers. That means this is our iterable, that is this list. Then for each number x, we check if it's even with x% 2 equal to 0. So for each number that is x, we are going ahead and checking if it's even with the condition x equal to true. If true, we add even to the list. Otherwise, we add odd. So every item is transformed into a string. No items are skipped. So if I go ahead and run this, so for every value, what we are doing is, so first it will take the value of 1. Then it will check for this condition. If it is x%2 is equal to 0. If this value satisfies, that means it is an even number. If this value does not satisfy, that means it is an odd number. So when it is even, we says return even string. When it is odd, we say return odd as part of else. So that is what you are seeing over here. 1 is odd, that's why odd is printed. 2 is even is printed. 3 is odd is printed. 4 is even is printed. 5 is odd, and odd is printed over here. Let's see our another example. So for every number x in the list, so every number for x in numbers, every number over here, if, so we are using the condition over here. So if x is greater than 3, we double it by using x into 2. Otherwise, we keep it unchanged. So whenever x is greater than 3, then only we are doing 3 into 2. Otherwise, we are going to keep it as it is. And all the original items are processed and added to the result list. So if I go ahead and run this, you can see if number is greater than 3. So 4 and 5 is greater than 3. So 4 2s are 8 and 5 2s are 10. So we have only modified the last two elements which are meeting this condition, which is if it's greater than 3, we are multiplying it. If it is not, we are keeping it as it is. Now we are going to combine with regular filtering. So over here, what we are doing is, first we are saying if x is not equal to 1. So this filters out the value 1 completely. Okay, so we have removed 1. Then for the remaining values, if x is greater than 3, it gets doubled, else it stays as it is. So the key factor over here in this expression that you will see, the filter, this is the filter. If x is not equal to 1 is at the end, while the inline if else comes in the first, and that order matters. So this example shows that how you are using transformation and filtering in a single list comprehension. I know it's a bit confusing, but as I run it, it will be easy for you to understand. So what exactly happened over here is, so as part of this expression, the first thing which ran was this. That is, if x is not equal to 1, it removed 1. So now it is not working on 1. Then it went ahead and started the iteration from 2. So so once it started from 2, every time the iteration was done, then it was checking if the number is greater than 3, it is going to multiply it by 2. Otherwise, it is going to keep it as it is. So 2 was not greater than 3. Okay, 3 is not greater than 3. That's why 2 and 3 are as it is. But the other numbers were greater than 3. That's why it was multiplied. So this is how you can use transformation and filtering together at one time as part of list comprehensions. Now, let's talk about nested list comprehensions, which allow you to work with multi-dimensional data or perform multiple levels of iteration. There are two main types. One is nested iterations and one is comprehensions as expressions. So nested iteration works similarly two nested for loops with each for clause representing a level of nesting. The order matters. So the leftmost for clause is the outermost loop, and comprehensions as expressions involve using a list comprehension within the expression part of the another comprehension. So these are powerful for tasks like flattening a nested list or transforming multidimensional data. In machine learning, nested comprehensions can help process image data or time series data with multiple features. But however, you have to be careful with nesting depth that you are providing. That means you have to be careful that how many nested loops you are using as part of the comprehension, because the more you nest, it can become difficult to read and it will become too complex, which kills the meaning of a simplified coding in Python if it is not properly readable, that is human readable. So I know this is actually a very advanced concept, but let's try to break it down with the code so that you can understand it better. So over here in nested list, what we are doing is, so we are using nested iteration, which is equivalent to nested for loops. So over here we have two for loops. Okay. So the first for loop is X, second for loop is Y. Okay. These are the nested for loops. So consider it for one for loop inside the other. So we are using two for loops, as you saw in one list comprehension over here. So for every X in the range of 3, that means it will iterate for 0, 1, 2. Okay. Now for every Y in the range of 2, it is going to only iterate for zeros and 1. So we create pairs over here of X and Y and collect them into a list. So, and that list is named as coordinates. So if I go ahead and run this, so how it starts. So X is going to iterate 3 times, that is from 0, 1, 2, and the inside loop is going to iterate only 2 times. So over here you can see that as soon as the first for loop runs, so first the value of X is 0. Okay, so it is going to go ahead and go inside the loop. Once it is inside the loop, we are only going to iterate 2 times. That's why you are seeing that first time the outermost loop is having 0, and when it goes inside, it will iterate 2 times for 0 and 1. So these are the two values. So then this is the second iteration of the outermost loop, where for X in range of 3, X will become 1 and it will go inside the for loop, that is second for Y, where you will see the Y values has changed and it has iterated for 2 times. Then it will again come out to the outer loop, and the value of X will become 2, and the other you can see 0 and 1. So it iterates 2 times for the innermost loop. So guys, look at this second loop now. What this loop is? Does it look similar to you? I will tell you how. So whatever I have performed over here as part of this code, so this is a list comprehension and this is actually the original code. So I have written this original code for you to understand how this list comprehension has been created. So over here, as I was saying, that we have first for loop. So you can see this is the outermost for loop. Then over here we have the innermost for loop. Okay. Then over here we have the X and Y. That is, this is how we have actually splitted our code, as you can see over here. So this is list comprehension, and if I go ahead over here, and you can see the values are the same. So this is how you have reduced this code to this code. I have just shown you this code so that you can understand that how this code has worked. So the real for loop that we have converted to list comprehension is this one: outermost loop, innermost loop, and the operation that has to be performed as part of that loop. Now let's go ahead and see another example. So in this example, we are having a 2D list, a list of lists. So this comprehension has two for clause, chain one after the another. So over here, if I say flattened is equal to num for row in matrix for num in row. So over here, this is the first for loop and this is the second for loop. That means the outer one and the inner one. So first for row over here, for row in matrix, it loops through each row, that is each sublist that we have as part of this matrix. Then for num in row. So first it actually goes through the rows in the matrix. Second, it goes via the numbers in rows, and it goes inside that row and grabs each number inside it. So in the first loop, we are going to grab the list. The second one, we are going to grab the numbers from the list. So that is how this nested for loop is going to work. So the expression part is simply num. So we collect every number for every row. So if I go ahead and run it, you'll understand what exactly we are doing. So the first for loop, what it does it, so it says for row in matrix. So this is the first row, second row, and third row. So at the first time, the outermost loop is going to pick the first row. It is going to come inside. Now, once we have the first row over here, num is going to iterate over that first row that we have, and is going to print each and every number inside that row, that is 1, 2, 3. So first time we did the iteration, it went inside this, it 1, 2, 3. You can see 3 values over here. Then it went to second one, that is second row as part of this 2D matrix. Then 4, 5, 6. Then the outermost loop picked the third row, that is 7, 8, 9, and then we iterate through the values inside that, and this is how you have your values returned over here. So this is how you can use list comprehensions in this scenario. Now, as we have seen list comprehensions, it's time for us to extend the comprehension syntax to dictionaries and sets as well. Dictionary comprehension uses curly braces with key value pair, as you can see on the screen, to create dictionaries, while set comprehensions uses curly braces with single expression to create sets. So both are using curly braces, but one uses key value pair inside that curly braces, and other one does not uses the key value pair. Okay, and both support filtering with if conditions, like we saw in list comprehensions. So the dictionary comprehensions are excellent for creating mappings such as word to count dictionaries in text processing or feature to value mapping in machine learning. And the set comprehensions are perfect for extracting unique values or creating sets of items that meet certain criteria. In machine learning, you might use dictionary comprehensions to create future dictionaries or set comprehensions to find unique categories into your data. So let's understand that with a few examples. So first I am going to go ahead and define a list over here. Once I have defined the list, now we are going to use a dictionary comprehension. What it is going to do is it is going to create a name and length mapping over here. So it is going to pick name and as a pick name, and it is going to allocate that as keys, and the length is going to be the values. So if you see this dictionary comprehension, what it is doing is so this is dictionary comprehension is denoted by curly values. Once you go inside the curly values, this is the for loop that they have defined. So this for loop where name is the variable. Okay, so what we are doing is it is going through each name one by one. Every time it picks one name, once it picks the name, then it's creating a key value pair, and in that key value pair it's saying name is the value of the name that it has picked as part of this for loop iteration is going to be one key, and the length of that name is going to be the value. So if I go ahead and run this, you will see first it picked Alice, and the number of characters inside it is 5, then Bob, then Charlie, and David. That is how you can use dictionary comprehension to create a name length mapping. Now we will use dictionary comprehension with filtering. So this builds over the previous example that we saw, but we are adding a condition. So if length is greater than 4, so only names with more than 4 characters are going to be included. Short names like Bob and others are going to be skipped. So same code as you see above. Only thing what we have done is, see till here the code is same. This is the extra if condition that I have added for filtering of data while we are running the loop. So we are controlling the loop over here. So if length name is greater than 4, then only then it is going to go ahead and create the key value pair. So over here, Bob length is 3. That's why it has removed it. But apart from that, the length which is greater than 4, that is Alice, Charlie, and David, has been printed below, as you can see. Now, next we are going to see set comprehensions. So in set comprehensions, what we are going to do is over here in the set comprehensions, we are going to loop through the list of numbers that you see over here, that is 1, 2, 2, 3, 4, 4, 5, which contains duplicates, as you can see. Now the expression x just adds each number to the set. Because sets are automatically going to remove duplicates, the result is going to be the collection of new values. So set comprehensions. So right now what we are doing is we are iterating through the list and we are saving it in unique numbers, which is going to be a set. That is, the return type is going to be a set. Over here the return type was a dictionary. Over here it is going to be a set, and by default the sets feature is it is not going to have duplicate values. So we are not performing any operation, it is going to happen automatically. So we will go over each number, okay, and we are going ahead and saving in set, and automatically set has removed the duplicate values, and here is the set that has been returned with unique values. Now in example 4, we filter the original list to include only even numbers, where you can see I have added a condition. So it is building over the previous example where we are iterating through all the elements in this list, but with a condition that it is an even number. So the result is set of unique even numbers now. So over here you can you saw all the numbers, but when I run over here, you will only see unique numbers. Even numbers that is added as part of this set. That is 2 and 4. Now let's go ahead and see what's next. Now we have seen how list comprehension works and how traditional loop works. So let's differentiate them. So list comprehension offers several advantages over traditional loops for creating lists. List comprehensions are more precise. It's often fitting the big lines chunk of code into a single line. What might take multiple lines with a loop, as we saw. So they can be more readable from simple transformations, making your intent of writing the code clearer compared to writing long codes. And they are often faster because they are optimized by Python interpreter. Very important point I'm going to show you next. Again, I'm saying list comprehensions are faster because they are optimized by Python interpreter. However, traditional loops still have their place. They are better for complex logic with multiple conditions or operations, and they can be easier to debug since you add print statements or breakpoints within the loop. While processing data for machine learning models, we use list comprehensions for straightforward transformation and traditional loops for more complex pre-processing steps. That means we are not saying that we should not use traditional loop. We are saying that wherever you see that we have a small conditions, not the complex ones, that is nested conditions, we can use list comprehensions and increase the speed of our code. But where there is a very complex logic and we have multiple level of nested conditions, that is nested loops along with the conditions, so it is better to use traditional loops over there so that we can add print statement. So for example, if I have 5 loops, so loop number 1 is the outermost, then 2, then 3, then 4, and then 5 is the innermost. So in the innermost, if I am getting any error, I can go ahead and print that, right? Then in the outermost, if I'm getting any error, I can go ahead and print that. So, and or if I want any condition to break any specific innermost loop, I can do that too by using break or some other statements, right? So that is how traditional loops are being used when you have a hierarchy of nested loops, that is loop inside a loop. Next, let's understand the performance benefit of list comprehensions. So it does not only make your code more precise, as we saw, but it can also perform better performance. It can also provide better performance. So they are often faster than the equivalent loop for several reasons. The Python interpreter can optimize list comprehensions more efficiently. There's less function call overhead since you don't have multiple append calls. Memory allocation is more efficient because Python can allocate the right amount of memory upfront. These performance gains are most noticeable with larger lists. In machine learning applications, where you might process thousands or millions of data points, these optimizations can add up to significant time savings. However, remember to balance the performance with readability, and overly complex comprehension might be marginally faster but harder to maintain. Let's understand this by an example. So over here, I am writing 2 for loops. So this is a traditional for loop that you see over here. That is inside with loop, and this is with comprehension, that is in one line. So I'm going to go ahead and run this, and we will see which one executes faster. So this codes compare the performance of 2 ways to create a list squares from 0 to 9999. So we define 2 loops over here. We define 2 functions with loop using a traditional for loop, and it creates an empty list and fills it with appending I into I, as you saw over here in each iteration. So this is simple, but calling dot append a million times, which adds overhead and takes longer. Then we define with comprehension. So this is the overhead that I'm talking about. Okay, for I into I, that is the append one. Okay, but over here we don't have to write append, it is automatically going to go ahead and append it for us. So then we define the with comprehension, which uses a list comprehension, as you saw, to do the same thing in one line. So Python internally optimizes this pattern so it runs faster and uses memory more efficiently compared to the previous one. So we use the time module over here. As you see, we are using the time module to measure how long each method that we have defined over here, that is each function, is going to take. So first we are going to time the loop version, that is with loop, and then we time the comprehension version. Oh, sorry, comprehension version over here, and then we are going to go ahead and print the output, that is the processing time, that is loop time that they used. So if I go ahead and run this, okay, it's not showing any output. We copy this and more code line. See, now we got it. Okay, sorry, it was taking time and I thought the code is not running. So the code ran. So the loop time it took is 0.716 seconds, and the comprehension time it took is 0.0561 seconds. So you can see the comprehension time for the same operation that we performed is less compared to the loop time. That's why I was saying list comprehension is faster than the normal traditional loops. So what are the common use cases where we use this? So list comprehensions are particularly valuable in data processing tasks in common machine learning workflows. They excel at data cleaning and transformation, feature extraction, filtering datasets, and normalizing value. So they are also useful for converting between data formats, creating encoding like one-hot vectors, flattening nested structures, and even generating synthetic data points. So the examples that we saw, it shows two common machine learning processing tasks, that normalizing data from 0 to 1 scale and creating one hot encoding for categorical variables. So these operations are fundamental in preparing data for machine learning models. List comprehensions make this task more concise and readable, helping you focus on the data transformation rather than on the mechanics of the loop. So that's all. Finally, we are going to go ahead and see the documentation that we have over here. So this is the documentation for list comprehension. Over here, you can see many of the examples that I spoke about is also available over here. I did use Lambda because we have not yet covered it, but you can see there are a lot of examples. See, if the expression is a tuple, how you can do, if the expression is equivalent to, see, how you can convert this. Multiple examples. See, call for a method, then create a list of two tuples, where you are going to get errors, how you can take care of it. Nested list comprehensions over here for 3D or 2D metrics that you have. So a lot of examples that you can go through over here. Now, thanks everyone for your time and participation. I encourage you to experiment with the concepts we discussed today. If you have any questions or thought, feel free to drop them in the comments below. I would love to hear from you. Remember, programming skills improve with practice. So try to apply these concepts in different contexts to solidify your understanding. Join our WhatsApp community, subscribe to our artificial intelligence and machine learning YouTube channel on which we are running this series, and sign up for our Tech Inside Neuron newsletter. All the links are being displayed on the screen, as well as I have added that in the description below. So see you in the next video. Take care and bye for now.